So in section 8.4, we're going to be multiplying special cases, and when we mean special cases, we mean multiplying binomials. So a lot like section 8.3. Special cases just means there's a certain couple kinds of binomials we'll be looking at here. So to introduce this concept, let's say if we start off with a square piece of paper that's 6 inches for the width and 6 inches for the length. If I was trying to find the area, that'd be 6 times 6. But let's say if I want to remove a strip from both sides, and that was the length of x on both of those sides, I could find the new area by finding 6 minus x for the length and 6 minus x again for the width. And just like in 8.3, we could FOIL this question, we could use box method, we could use distribution. But either way, we'd multiply out and we get something like 36 minus 6x minus 6x plus x squared. And if I combine like terms to get our final answer, we get 36 minus 12x plus x squared. So really everything we're going to be seeing in this section is something we could have solved in the last section. Now we're just going to have a shortcut for it. Because another way we could refer to this question is just like saying 6 minus x. Now I just raise that to a power of 2. So that means that we're going to have special rules that we're going to use to simplify what we call the square of a binomial. That's what we saw last time, 6 minus x squared. Or another rule for what we're going to use as the product of a sum or a difference. So squares of binomials are in the form a plus b quantity squared or a minus b quantity squared, a lot like our first example. And that means we can algebraically simplify the product, or you can use an area model to discover the rule for simplifying a plus b squared as shown below. So this is really just like saying we could have used the methods from last section to solve the same problem. So let's say if I was picking FOIL method, we got our box method off to the side over here. But let's say if I want to FOIL this, I could multiply first terms together and get a squared. I can multiply last terms together and I get a times b. Then if I multiply the inside terms, well, let's do that on the bottom, inside terms together, I get b times a, and last terms I would get b times b, so that's giving me b squared. Even though it's out of order in the middle, ab and ba, those are still like terms. That would be 2ab once I combine them all together. So again, could have done this in the last section, already got our answer, and that would be a squared plus 2ab plus b squared. What we've actually done is discover a shortcut. Because since we can only deal with this square of a binomial and it's not going to change, that means I'm always going to be getting this result. So bringing us down to our key concept, square of a binomial, we've just found the formula for it. Square of a binomial is the square of the first term, so that's your a squared, plus twice the product of the two terms, that's plus 2ab, plus the square of the last term, so that's plus b squared. And that's going to follow that step every time as long as I'm dealing with the square of a binomial. So for example, if I have x plus 4 squared, square the first term, twice the product of both, so that's 2 times 4 times x, that's 8x total, and then square the last term is going to be 4 squared, which is just a 16. If I throw in a minus b instead, doesn't change too much, just means I have square the first term. Now since it's negative, now I'm just subtracting 2ab, and then my last term, since a negative b times a negative b, still going to end up as a positive b squared. So we see that next example. X minus 3 quantity squared, square the first term. We have the twice the product of our two terms, so 2 times negative 3 times x, and then square of the last term, we get 9. So really all we got to do in these questions is recognize what's our a term and what's our b term, and then we can just follow our formula. But remember, all these questions can still be solved using the same steps we did in 8.3. So let's say if I start with n minus 7 quantity squared. We're looking for an a term. In this case, that's just n. If I'm looking for a b term, my second value, that's just negative 7. So if I was to follow the formula, I just got to make sure I'm plugging in the right spot. So a squared, that's going to be n squared in this case. And since we're dealing with a negative, this is going to be minus 2. And then again, a was our first term, and b was our second term. We're just going to use that 7 there. And yeah, since we're using a 7, let's get rid of that negative. And then for our last term, again, that was the square of our last number. So that's b squared, which in this case is just going to be plus 7 squared. So using our shortcut, n squared can't do much with. In the middle, negative 2 times 7, I got negative 14. We've got an n there as well. And then we just got to make sure to simplify 7 squared and just get 49. So I didn't need to use box method, didn't need to use FOILing, didn't need to use distribution. I just need to use my shortcut. So again, starting with that next question, I just got to identify what's my first term, that's 2x. What's my last term? Looks like that's just a 9 all by itself. So now let's just follow the formula again. So if I'm following my formula, I do got to make sure that I'm squaring both of those pieces on my first term, not just squaring the 2, not just squaring the x, I'm squaring the whole thing. but then I follow the rest of the steps. So 2 times the first times the second, and then I square that second term. So simplifying that down, we've got to make sure again to square both parts. So that's going to be 4x squared for our first term. 2 times 9 times another 2, looks like that's going to be 36x in the middle. And then 9 squared is going to make an 81 for our last term. That again is already simplified. We don't have to do anything else with it. We don't have to FOIL, box, or distribute. We just followed our shortcut. So I'm going to skip C, running out of some rooms. If you guys can do that one by yourself. But I think with this last one, because that's another first term is 2n, we have a last term, which is just 3. And now if I follow my formula, I can square the first term. In the middle, we do got to make sure that I'm using that minus. So minus 2 times both terms, 2m and 3. And then the square of the last term looks like that's just going to be 3 squared. Got to remember that that last term is always positive. Whenever I do a negative times a negative, doesn't matter. Going to come out to a positive last term. So the same thing as our last one, we got 4m squared. Then it looks like in the middle, negative 2 times 3 is going to make negative 12. Got an m there as well. And then 3 squared is just going to make a 9. So again, just using our shortcut, square the first term, twice the product of both, and then square the last term. You can do this also in a word problem. So if I was trying to do this word problem, we can really skip past most of it and just get to what's essential. If I see that I'm trying to find the area of this walkway, so walkway looks like it's going to be just this portion outside the patio. And we know that the entire thing itself is x plus 6 and x plus 6, so that's starting off with a big square. But then I also have this patio on the inside, which is just x and x. So if I wanted to find just the walkway area itself, I can start with that big square, and then I could subtract the smaller square from the center. So I'm subtracting just that x squared, and then I can just simplify my result. And for that first piece, x plus 6 squared, that looks like that's going to be our shortcut. So square the first term, twice the product of the first term and my second term, so 2 times x times 6, and then I square that second term, so that's 6 squared. So if I'm simplifying that down, x squared plus 12x plus 36. One difference on this question, remember since we're subtracting the area of that inside patio, I still need to take away x squared from this. So if I'm combining like terms as the last step, looks like there's x squared and x squared. X squared minus x squared is just going to cancel, and I'm just left with 12x plus 36. Throw in units too, since that word problem looks like 12x plus 36 is going to be our quantity in terms of feet. So again, all we're looking to do really is simplify this x plus 6 quantity squared, following our shortcut for scoring a binomial. So let's suppose the walkway is 4 feet wide instead of 3 feet wide. Doesn't really change much, because again, instead of adding 3 feet on each side, we're adding 4 feet on each side. I'll just set up that question. I think you guys could probably solve it. It just means the only difference is now we'd have x plus 8 quantities squared minus still that patio from the inside, minus x squared. Which again, x plus 8 is coming from that 4 foot wide patio, but that's on both sides. So see if you guys can simplify that. I think that's going to be a lot like that last question. Again, all we got to think of is how can we follow our shortcut to simplify that binomial. And if you're afraid of using that shortcut, remember you can always fall back and use your methods from 8.3. So if I do have a different type of special case that the title referred to, referring to the product sum and difference of the same two terms, means it's also going to have a pattern, it's also going to have a shortcut. And this is actually a little bit easier. So let's say again, if we want to go back and do this one old-fashioned, we want to FOIL it. I multiply first terms together. A times a is a squared. I multiply last terms together, so a times negative b is negative ab. And then I multiply the inside terms together, that's a positive b times a. Last terms looks like b times negative b is going to be negative b squared. So in this case, we do have like terms, but they actually cancel each other out. If I notice a minus ab and a plus ba, remember even if the order of the variables is not the same, we have the same power, we have the same variables, so those will actually cancel each other out. All we're left with in that case is just a squared minus b squared. So that's why this is actually a little bit faster shortcut if I notice this as a starting point. So the product of the sum and the difference of the same two terms, again, always going to be a shortcut. It's just going to be the difference of their squares. So as long as I know the first term's a, my answer is going to start with an a squared. As long as I know my second term's b, it's going to end with a b squared. And all I'm doing is finding the difference, so that's just a squared minus b squared. So again, it does have to start with this certain type of example, something like x plus 2 and x minus 2. square the first minus the square of the second, and that just means it's going to be x squared minus 4. Really quick question to answer. We don't have to use any type of method. We just have to use this shortcut. So if I want to find a simpler form of something like x plus 9 and x minus 9, as long as I'm squaring the first, subtracting the square of the second, that's already basically our answer. One thing we got to do is simplify that. We know 9 squared is going to make 81, and we're done. So if I'm trying that again, we just got to be careful about something like an m squared on this next example. We know that our first term's 6, so we can start with a 6 squared. We're always subtracting in this case, so again, not like that last question where I could be adding. A positive and negative is always going to make a minus for that last term. If I'm squaring m squared, we got to remember to be careful with that exponent. 6 squared is going to make a 36, but if I'm squaring m squared, that's going to result in m to the 4th power. Remember, we'd multiply that, so 2 times 2 would make a 4. 2 plus 2 makes a 4 anyway, but that was just kind of lucky. 36 minus m to the 4th, that's already our solution. So let's try that again with the next one. So again, a couple quick questions you guys could probably do ahead of time. We know our first term's 3c, so as long as I'm squaring that, that's already the first part of my answer. We know our second term is 4, so if I subtract that square, let's just simplify. 3 squared is 9, c squared as well. 4 squared is going to make a 16. We're done without having to use any kind of longer method. And getting to that last question, looks like we have to take x to the 3rd and square it. We also have to subtract that second term squared. And this is where we got to go back and be careful about our exponents. Again, this should not make x to the 5th power, x to the 6th power instead. Whenever I'm taking a power, we got to remember that we're multiplying. So always finding the difference using this shortcut, but 8 squared is going to make a 64. And that's really it. That's our two types of questions. We have the product of a sum and a difference that we just did with our shorter shortcut. And our first situation where I have the square of a binomial also has a shortcut. We're just going to have that answer as a trinomial. So we have a lesson check at the bottom. I'm going to pause for a little bit. You can pause that video. I'll reveal the answers in a second. Just want to see if you guys can check your work first and see how you did. So getting ready to check that work. Let's see how we answered. And yeah, I've got a couple products of a sum and a difference. That was our shortcut, c squared minus 9. Number 3, same thing, 4r squared minus 9, pretty fast. And then number 2, I've got the wrong answer there actually. Let me fix that one. This is a good one to practice. So if I'm doing g minus 4 squared, I followed the wrong shortcut. Let's try to make sure not to do that. If I'm following this shortcut instead, notice this case I'm not doing g plus 4 and g minus 4. In that case, I would have a squared minus b squared, so kind of like that other shortcut. This is the type of question where I have to square the first term. I'm using subtraction, so I have to go to subtract in the middle. 2 times the first times the second term, and then we're always going to add that second term squared, so plus 4 squared. So trying to simplify our answer, g squared minus 8g plus 16. That's correct instead of what I had written down before. We do have the same type of question on that last one though, so number 4 is just like that one I corrected for number 2. If I was trying to do a square with a side length of 2x plus 3, that's a square of the same binomial, so that means I'm using my longer shortcut, 2x squared, and then 2 times 2x times 3 in the middle, then 3 squared, and this is where I get my answer as a trinomial. So again, these are good shortcuts to use if the question starts off a certain way, but if we get confused, always can fall back to 8.3. So give this a shot. We'll see if we can do this homework as well.